Alright, so now let's configure Netflow. We've got a very simple network here in GNS3. We've got 10.10.12.0 network on the left, 10.10.13.0 on the right. Um, the last octet for each router is its router number, make it easy. So what we'll do here is we'll have router 1 perform Netflow. It will do fast Ethernet 0.1 performing ingress Netflow, and we'll have router 3 and router 2 communicate between each other by sending pings, and we will take a look at what we can see on router 1 with Netflow. So we'll go into 0.1, fast Ethernet 0.1. Command to configure an interface for Netflow is ipflow. Then you've got the option of ingress or egress. Let's do ingress. So let's see if we need anything else. Let's see what show commands we've got. So we just did ipflow command on the interface, so maybe there's ipflow show commands. Let's see what those look like. So we've got export, interface, and top talkers. Top talkers was that feature we saw in the theory showing the heaviest usage flows. We won't look at that now, but it's good to see that that's how we can take a look at that. So let's look at the first one. Let's look at ipflow export. So right now we can see it's disabled. We can also see that it looks like version 1 would be the default. And it's makes sense, it's disabled. We didn't configure any Netflow export. Let's take a look at what all these, these are all kind of error messages. So first of all, we can see UDP datagrams. So we can remember back in a theory that we saw that UDP is used for Netflow. So what does this mean? Flows fail due to lack of export packet. Well, I've actually got some Cisco documentation pulled up that explains these. So lack of export packet actually means because no memory was available to create an export packet. So think of the Netflow is creating statistics. Now it needs to export it. So it creates an export packet. But the flow failed due to lack of export packet. It doesn't really explain exactly what lack of export packet. Why was there a lack of export packet? Well, this error message is because no memory was available. So it'd be something you want to know. Sent to process level. See what that means. Right here. Could not be processed by CEF or fast switching. Here's some more that have to do with CEF. Drop due to no fib. Drop due to adjacency issues. Total number of export packets, CEF was unable to switch or forward up to the process level. We've got fragmentation failures, encapsulation fix-up failures. These are just more self-explanatory problems constructing the IP packet. Here we've got drop due to output drops. So that's because the send queue was full while the packet was being transmitted. So now we kind of know about this. We know what these mean. Lack of export packet. Wasn't able to create the export packet because there's no memory available. We've got process level, fib, adjacency. Those all have to do with CEF being unable to process. So let's see what else we have. We have show ipflow interface. And this is going to display the flow configuration on our interfaces. And this is a very simple and concise show command. We see fast Ethernet 0.1 has the command ipflow ingress, so performing ingress Netflow. So let's see the command to show Netflow statistics, and that's show IP cache flow. So let's start at the top, see what all it shows. You can see this command is one of the Netflow commands that gives you the most output, the most information. So first we've got IP packet size distribution. This is going to show us the percentage of all the packets that Netflow is recording and how it's distributed. So all these numbers are bytes. You've got 128 bytes, 160 bytes, etc. Here, we've got some interesting information, particularly these two lines, active flows timeout and inactive flows timeout. So what do those mean? So active flows timeout in 15 minutes, that means that if you've got an active flow where it's just continuous, there's no break, no long periods of breaks between packets being transmitted. But once you've got 15 minutes of that, it's just going to cut that off and so that it can be exported instead of having some gigantic flow. Inactive flows timeout is where if the flow stops being active for a certain time, it's going to cut that off and send that so that it's not waiting around for minutes and minutes and minutes for a flow that might not even be used anymore. So actually, I already had changed the configuration from previously. So these actually are not the defaults. Let's take a look at what the defaults are. So if we look at the running configuration, let's see if we can see. So I had actually already configured this, so let's take these off. What did I say for that? 15, I think. So let's go back to our show IP cache flow command. Okay, so now we've got the defaults back on. So defaults for active are 30 minutes. Inactive is 15 seconds. So, why don't we go back and see how we configure that? I did that a little quickly. So the command to configure the flow timeouts is going to be IP flow dash. Let's look at these because there's a lot of different commands available. So there's flow egress, flow top talkers. There's that top talkers again. Flow export. We use that to configure our point to our export, our Netflow collector. So it's IP flow cache timeout. Then we specify active or inactive. So active is in minutes, and you've got only a maximum of 60 minutes. So let's make that 50. And then let's do inactive. That's going to be in seconds. Let's make that 500 seconds. Let's go back to our command, show IP cache flow. So here's some more counters. This is interesting. Last clearing of statistics. By default, that actually will say never. I had configured this previously, and I actually cleared the statistics with clear IP flow, I believe. Yes, clear IP flow statistics. So that's why it says it was about 9 minutes ago. And then here's where you'll have the statistics. You'll see total flows per second. You'll see all the those fields, those 7 fields that need to be matched. You'll see those right here. So let's create a flow. So it looks like, as far as we can tell, it's working. All we needed was that IP flow ingress command on fast01. So let's create some traffic. Let's go into router 3 and let's ping router 2. And let's repeat, let's say 50 times. I'm going to router 1 and look at our show IP cache flow again, see if anything's changed. Okay, so we see some new information. The first thing I see is this 50 total packets. So we just sent 50 pings. That was 50 packets going into fast01. And we can see the IP packet size distribution. We've got 128 byte counter is at 100%. So 100% packets are of that approximate size. Now we've got one active flow. And let's take a look at this. So we've got, right now this flow, because the timeout is 500 seconds, this is still an active flow. So that's why it's not presented here. These statistics are presented once the flow is over with, once the inactive timer has reached its whatever its timer is. So that's why this is all you can see right now is you've got source IP address, destination IP, destination interface, source interface, got a protocol number, source port, destination port, number of packets. Now let's do that again and do a capture on it so we can see in Wireshark how the fields are corresponding. All right, looks like it's not starting up. Okay. So let's do ping analyst time. Let's just do 3. So let's look at, so we've got 6 packets here, obviously because we've got from router 3 to router 2 and then the reply. But we're only monitoring in fast01, which will be with router 3 source. So let's look at that. So we've got protocol right here, ISMP 1. So that matches in here, this protocol right here. The PR stands for protocol. So it's number 1. Of course, you can see source, destination right here. But this kind of shows you that each packet, like we were saying, has to match 7 fields for it to be considered a flow. And this is showing you those. It doesn't show you type of service right here. But now let's make that flow timeout. The inactive flow we have right now is quite long. So we've got IP flow cache, right? Yes. Timeout, inactive. Let's make that 30 seconds. So now that flow has timed out, and now we can see some new statistics about it now that it is a completed flow that has completely timed out. So there's one flow with ICMP protocol, flows per second 0. I mean, there's so many seconds that the average went out to 0. Packets per flow, there's 53. We did 50 pings, and then we did 3 bytes per packet. Packets per second. Another thing I wanted to point out was that we can see here the length is 114, yet in the IP packet size distribution, it's kind of as 128 because it's kind of rounding. It doesn't mean it was exactly 128. It's just showing you the nearest number here. So let's try something new. Let's try the flow sampler. So what flow sampler does is, let's say you had thousands of packets each second, and it was too much to monitor. You only wanted, say, like a sample. You wanted 1 in every 100 packets or something. You can configure Netflow to perform that sample instead of counting every single packet. So let's see how that works. We'll go into flow sampler map, I believe. Yes. Sampler map, we'll give it a name. Let's call it CCNP. That's it. See what our options are. It's just to exit the mode or configure the mode. So we're going to do mode, random, 1 out of, whoops. So all you can configure, you can randomly match 1 out of X number of packets. Let's say 1 out of 25. That's it. So let's so now what we have to do is we have to apply it to the interface. So we want to do it to fast01 like we're doing with Netflow. I believe it's IP flow sampler, and then the name of the flow sampler, we've named it CCNP. If you complete it, it's just going to be ingress, or you can specify egress. So once again, to configure full Netflow, you use IP flow. To configure the flow sampler, you do flow sampler. Just as how in global mode, there's no IP in front of it. All the IP flow commands start like that, but the flow sampler is just flow sampler map. and it is the only command that starts with flow by itself in global mode. So let's see how that works. Well, so now it's matching 1 out of 25, right? So the command to look at that is show flow sampler. We can see our name, CCNP, packets match 0 so far. We haven't sent any packets. Mode is random sampling mode, as opposed to previously you could use sampler maps to match every nth packet. So matching 1 in every 25 packets, it would match packet 1, packet 26, packet 51, like that. But this is actually random sampling. Sampling interval is 25. So let's send some packets. So if we send 50 packets, we should expect 2 to be recorded by Netflow because it's sampling 2, right? So here's 50 packets sent, and let's see what happens. Wait a minute, packets match 0. So why is that? Why are only 0 packets matched? We're sampling 25, we configured on the right interface. Well, the problem is that the flow sampler cannot work with full Netflow working as well. So if you want to use flow sampler, you actually have to take off your full Netflow. So right now, as we saw before, IP flow ingress is the command for full Netflow. So we have to actually take that out. So let's go into fast01, do a no IP flow ingress. Let's look at our flow sampler again. Now let's do that again. All right, so now it's working. Now we've got 2 packets matched. Let's take a look at show IP cache flow. You can see that it looks just like the others. It's now, but we sent 50 packets, but we've only got 2 packets matched right here. So that's what flow sampler map will do for us. It will show us the same statistics as we see before, just now instead of matching every single packet, we can match 1 in X up to, you saw, 65,000, whatever. Let's look at the flow export command. Obviously, I don't have a Netflow collector to configure to this right now in GNS3, but let's just take a look at the commands so that we're familiar with them. So we saw that the flow sampler is the only one that starts with just flow. So we've got IP flow, and then export. Let's configure the export. So we've got destination, source, which is not needed, template, and version. So if we had a collector at, let's say, 10.10.13.5, we'd also have to specify the UDP port number. Off the top of my head, I actually forget what the port number is. Let's see if we can do that. Look that up real quick. Netflow export. Oh, okay, that's right. 9996. I've seen that used. So let's configure that. 9996. And that's it. And then we should also configure the version. So as we can see here on my router, I've only got the option for 1, 5, or 9, even though we saw that technically we should be able to use 7 and 8 as well. We've only got those 3 options. And we saw by default, we can do it again, IP flow export. So right now it's enabled because of that command. We're exporting flows to this IP, this port, using source 13.1. It's using version 1 by default, so if we want to change that, just do IP flow export version, let's say 9. Now we can see it's changed to version 9. So I think that does it. We saw a few commands that were pretty succinct, such as show IP flow interface, show flow sampler. Those are very brief. The real big one is going to be show IP cache flow. It's going to give you the most information. We also saw how to see information about export, configure the different versions. So hope this has been helpful.